Now we will move on to our next lecture, and that is on framework and implementation. Now we have understood the background. Now we are discussing about framework and implementation of risk conscious maintenance management in this lecture. So let us say what is the framework? Framework means a broad skeleton which gives me a canvas, big canvas, what is what and what. So here we have as part of that framework, what are our core values? Because when we talk of framework, we should also define our core values and requirement. Then only management will understand. Okay. So the first core value is risk-based management as an overriding factor. No, come what way, or even in extraordinary case, if it is required that somewhere the safety is compromised, then regulatory will discuss about that. Regulatory agencies, they allowed small increase in risk, 0.1%, 1%, 1.2%, but then regulatory clearance has to be required. Otherwise, the standard heuristic rules is safety is an overriding factor. Okay. Then human and organizational factors are the backbone of maintenance. So yeah, this is very important. Core value of this risk conscious maintenance management, provision of risk based management task force. We have to have dedicated cell which will be operating on this thing. Apart from this cell, if I talk about the maintenance and all, then maintenance, there will be a maintenance sort of control room which will take decision based on these holistic approaches, and CQB model form basis for human. So the standard human reliability model that has been discussed earlier in I think 7th or 8th lecture, that form the basis of risk conscious culture, because other models they might not have an integrated approach for security modeling, and then which is ethical factors, and consciousness and cognition, that relationship which was in a crisp manner, which was dealt here in CQB model, that is required, is parts of it form part of the core value. Risk conscious culture with human root cause analysis. Please look at this, because in one of the lecture we have seen why not in line with hardware component have a fault-free model of human also, so that we don't get away with mistakes and lapse or error of commissioning. We should be able to give that much respect to the human, under what circumstances, with what limitation, what were his apprehension, and that led to the human error. So through this risk conscious maintenance management, we are considering human root cause analysis and hardware root cause analysis. So I would say human root cause analysis was inspired based on the hardware root cause analysis. If I have a diesel generator, if I see failure due to lube oil, failure due to starting air, failure due to some electronics problem, so why not we discuss human also? Why we stop at human and we say okay, this is what it is, and it is a cognitive error, time window that was available. Let us go in detail and give human the respect it deserves. You might feel that those things might reflect either on the organizational thing, or it might relate to some design fault. So 90% we consider human as a man-machine interface aspect. That thing will go off, and requirement. Quality PR is available. Defense in depth implementation we cannot, because at present we are having an informed system. But of course, like risk based engineering, we have a technology. So there could be many jobs which are risk based. There are other jobs where decisions are more important. It becomes risk informed, be it regulatory or in an operational ecosystem. So risk informed and risk based criteria available for decision making. This idea should be available. That means risk matrix should be available, and then plant's throughput matrix also should be available. A policy statement is available for implementation of RCMM. unless until organization shows interest and they are motivated by looking at the characteristic, it is not possible to implement the. So this is a special requirement, could be administrative requirement, but it is required. Now the framework is like this. It has got three major components: technical module, RCMM rather. Okay, it has got technical module, it has a management and coordination module, and it has got risk and reliability module. Okay, we will discuss all the three modules in what are the function, how we are trying to address the technical issue, management issues, and risk and reliability issue. And then requirement, again, if I have to extend that, RCMM center, like we say maintenance management center, risk conscious maintenance management center, it will be upgraded. Traditional maintenance center will be upgraded to risk conscious maintenance center. Is fully functional. A computerized maintenance management model should be required. These are the minimum requirement. Risk monitor platform should be available, or even a living PRA, I would say. Living PRA, that means I approach a PRA expert, I will say these are the changes. Can you run this, or can you perform a simulation and tell me what is the impact on the net system availability or code damage? So at least living PRC should be available, and then trained staff is required to efficiently for management of, and there here I am highlighting coordination, updating and reporting and management activities. These are the activities which don't fall anywhere, but then it is called as human error in communication here. So, these activities should be really monitored, that there should be few or there should be no lapses here in terms of. So, either it should be through written thing, but every time written is not possible. So, there should be a recording mechanism, what was communicated, what was done and all that. So, those kind of system. So, I will discuss these three modules in the next slide. First, I will take the, okay. So, I will discuss first, before I go to the respective module, I will give the big picture of for implementation, because when we relate what is there in the module and how it is implemented, then only gap area, and then we will follow those things actually. So, organizational mandate, as I told you, there should be a plant policy. There should be provision of resources, a computerized maintenance management system, yes, and it should be tailored to our plant's requirement, number one, and having a connectivity with the PRA model of the plant. So, that kind of thing, it can happen only in the plant ecosystem if organizational mandate is there. Then there should be a clear-cut statement or policy statement why RCMM is being brought out and what are the benefits to be drawn and how people should follow this policy while doing their certain job. And these are all implementation related. Requirement specification, clearly brought out requirement specification touching all the tasks, all the activities, all the communication, all the coordination job, because unless until it is explicitly told to all the employees at management level or organization level, we will not accrue the benefit. And then optimum inventory policy. We saw one lecture on inventory management. Because shortage of stuff available in the stores or tool creep, they often create issues actually, delays and all that. So, and sometimes financial losses also, or sometimes it has got a risk related connotation also. Now, decision support system. A efficient risk monitor should be available, human factor assessment and training. All these activities should be connected to the training. So, training should get training module, it should get all the feedback, how they have to upgrade their training program or what kind of additional program they have to impart to their employees. It might be related to new equipment that has been brought. It might be related to the errors which have been taking place in the plant, relatively more frequently, or some event has happened and which need a consciousness how to work in the plant to reduce the risk and all that. And root cause analysis is a very powerful tool, and it helps in having the safety culture thing and all, what is going on in the plant, and tracking performance feedback, and then finally going into feedback mode. So these are the implementation. So we saw the framework, we saw what we want at the implementation level. Now major requirements are prerequisites. Before we do that, so if somebody wants to implement it, so what are the prerequisites that are available? Drafting of a policy. It is not an easy job. As I told you, it is somewhere in the beginning of the things. Maintenance management, spare part, everything. It is recommended that even designing an optimum inventory will be a task in itself, and that will be governed by what are the past data that are available. So it is a very resource intensive task. It is recommended that the maintenance management must meet some code and standard available in the. This is one of the best practice that could be there, that we go back to our data, and then not data, standards that are available in the area, maintenance management, and then we tailor our policy or our working method based on this. Keeping in view the lesson learned from human error, the training of qualification, as I mentioned in my previous slide, training program should be dynamic in nature. It should not be static, that it is manuals are written and then it is followed for years. No, that means we are avoiding so many inputs that are available to us, and we are not using it in our manuals, our practices, our methods and all that. So it should be very dynamic program. A computerized maintenance management, yes. A RCA policy should be there. That means a particular event, it should get the attention of level 1, level 2, level 3 that we have discussed. So it should be brought out very clearly. If the fractions are more, then also RCA, even though it might be a routine thing, because it might percolate down to safety system, you don't know. So that kind of symptoms should be used. RCA policy for hardware and human and all level. Regulatory approval is very important before we go for any broad change in policy, and review of maintenance procedure complying the change management. As we have discussed. So everything, if I read these things, they are in dynamic way actually, not in the static way. So now let us come back to what are our technical requirements and upgrades. So you can see here, maximum diamonds we'll get when we review our maintenance program, existing maintenance program. Let's take last 10 years of data and see the strength and weakness of our maintenance program, and then in the light of the new knowledge that is available, improve it. And obviously root cause analysis is what the RCMM is trying to promote, and root cause analysis also not at hardware level but at component level. So RCA is one thing, and these two together will give us a culture and technical gap. To be very explicit, it will give a culture of risk conscious culture and technical gap that is available. It could be technical gap also, it could be human factor gap also, but let us put it in the category of technical gap, whatever was available. And revision of maintenance procedures, and I would say in dynamic ecosystem. And finally, closed loop training program should be modified. So this is the objective of our technical module. If I have to tell in one word, it is that we have to have a dynamic program, dynamic procedure to implement the technical aspect of the risk conscious maintenance management. And we have discussed RCA and RCMM, periodicity and all. They should be also dynamic in nature. Drafting a policy statement must be the toughest task, but we always draft the quality statement for our organization. So for a small module of that is, if you can include at the policy statement itself, we will be going for risk conscious maintenance management directly or in implied way. Probably it will become part, or we have to develop separate policy statement for this. Okay, then management module. If we define, we have to define the goal, what we are trying to achieve. Obviously for us, for risk critical system or safety critical system, it is the highest safety that we want to maintain. And maintenance management is one of the input So then our requirement specification should bring in these aspects of course, safety is the top note, then how maintenance is going to support it, how operation is going to support it, and then there should be all these things should percolate down to organizational mandate. What is the organization's mandate? Yes, safety and reliability, but then how? So those mandates will come out a document. These are all central document. They will percolate down to their respective procedures, methods, and all that. And then we have a logistics and management. Yes, lot of logistics management you have to for implementation. You have to bring in risk monitor. You have to bring in computerized maintenance management. If not available, it is here. And a sort of a decision support system will come to this level, and field activities and supervision. The more you are in field and intimately know the equipment, the better it will be for every staff. I mean, if I have to perform, I have performed some maintenance on this thing. If I visit it at least for that day, every hour and see what is going on, probably many of the latent error will precipitate out. Otherwise, we'll know when it will be. So it will save the plant from tripping or going into the unsafe manner. Plant performance indicators, and finally, it comes down to developing plant performance indicator in terms of broad factor will be availability, reliability, number of trips, number of shutdown, outage factors and all those things, and then any event has happened, why that event has happened. So it is available for everybody in an integrated manner to see these things, So here we are talking about so many tools, methods and all which becomes part of technical management. And finally, it is the risk and reliability module. Level 1 PRA should be available, as I mentioned in the prerequisite also, and we should be very clear about the core damage frequency. Not only core damage frequency, but the uncertainty associated with the core damage frequency, upper and lower bound of this thing, and what kind of variability the plant can accept. That means there can be a discussion, and we can understand the margins safety margins that are available, and then it becomes a part of the statement. That means change in core damage frequency, how much? So a band will give, and that's how we will be able to capture the uncertainty also. And then major items that we are trying to understand is allowable outage time, test and maintenance interval, test maintenance activities dynamically addressing the failure mode. We do maintenance, we feel we'll do this, but then in a long run we'll see whether this particular maintenance we are doing, whether it is required or not, or some failures are happening somewhere else, and we are doing maintenance on routine basis somewhere else. If there is some electrical fault, sort of overload thing, then whether it is originating from mechanical side or whether it is originating from electrical side, if we analyze that, probably we will know where we have to increase the maintenance. So crosstalk will be there between electrical and mechanical maintenance, and both of them they can decide, okay, this was this, and then our mode of maintenance also will change. So what I am trying to assert here is, it should be in dynamic sense. It should not be periodic preventive maintenance, do this task and come back. No. You see, you acquire additional information, why the component was failing and all that, and sometimes this industrial safety data and insight that also go into the risk matrix, because industrial safety is a very important matrix in the plant actually. CDF and all is okay, but even though effects are local, and then finally feedback goes into the next module that we have seen in the first slide. And if we have so we have seen the framework, RCMM framework, we have seen major elements of the framework, and now we are all geared up to take some practical example, So in next lecture we will discuss a practical example of risk conscious testing and maintenance management.